So if you're talking about x squared is the same as x times x. That goes way back to like elementary math days. X times x equals x squared. So I squared would be like I times I, but we just said I was equal to the square root of negative 1 times the square root of negative 1. If you have the square root of a number times the square root of that same number, it just becomes the number. So like if you have square root of 5 times square root of 5, it becomes 5. So if you have the square root of negative 1 times the square root of negative 1, we are now going to say that anytime I have an I squared, it is equal to negative 1. Because two square roots of the same thing cancel the square roots and become the number. I cubed is the equivalent of I 3 times, or you can think of it as I squared and I. And we just said all I squareds are negative 1. So again, I cubed would be like root negative 1 times square root negative 1 times square root negative 1. So we know 2 square roots of negative 1 become negative 1. And we know that the square root of negative 1 becomes I. So from now on, anytime I have a problem, if that problem has I cubed in it, then I want to rewrite that as negative I. So if I have a problem and it has an I squared, we're going to replace it with negative 1. If it has I cubed, we're going to replace it with negative I. I to the fourth, just like x to the fourth, x to the fourth would be like 4 x's, but 2 x's are x squared. So x to the fourth is really x squared times x squared. So we could say I to the fourth is really I squared times I squared. And we just said that I squared was negative 1. So negative 1 times a negative 1 becomes a positive 1. So all I to the fourths are going to get replaced with 1. Powers of I have a pattern of 4. Powers of I have a pattern of 4. So if you went over here and you investigated I to the fifth, that'd be like I's 5 times, which would be I to the fourth times a single I. I to the fourth is equal to 1. 1 times I is going to equal I. I to the sixth would be 6 I's. But you can really think of that as 4 and 2. We always go back to 4 because 4 is positive 1, so it's like the easiest to get rid of. So I to the sixth is really the same as I squared, which is really negative 1. 7 would be 4 and 3. So I to the 7, take away your 4, means I to the 7 is the same as I cubed. I cubed is negative I. All multiples of 4 are the same as 4, which means they're 1. All i's to a multiple of 4 are always a 1. All i's to a multiple of 4 are always a 1. What you'll notice is off to the side, I have the word remainder. You guys love your calculators. If you can't figure out where it belongs, you can use the remainder theorem. So the remainder goes like this. What comes after 8? The number 9, right? So I to the 9 should be the same as I to the 5th. So what you do is on your calculator, you take the number 9, divide it by 4. So what is 9 divided by 4? 2.25. Ignore the 2. The remainder is 0.25. If when you divide a number by 4 and the remainder is 0.25, where the decimal is 0.25, it is equal to I. So when you divide this number by 4 and your decimal is 0.25, it's equal to I. So what comes after 9, the number 10? Take 10 divided by 4. What's the decimal remainder? 10 divided by 4.
Oh, God.
Anything with a remainder of 0.5 is going to be equal to I squared. So again, if you want to memorize the patterns and you want to memorize decimals, these work the same way. 11 divided by 4 has a decimal remainder of, thank you. So if the decimal remainder is 0.75, it is together negative I. And I squared, instead of writing I squared, you would write negative 1, sorry. And then if your decimal remainder is 0 or nothing, it's the equivalent of I to the 4, which is 1. Some people like to look at the decimals and just memorize this way. It's whatever works for you. I just kind of look at it and say, okay, it's a multiple of 4, so it goes here. So I to the 13 is one number after a multiple of 4, because 12 is a multiple of 4. I of 13 is one after. After your multiple of 4s, you go back to the beginning, which is I. So I to the 13 is I. If you took 13 and divided it on your calculator, you would get 3.25. Decimal remainder of 0.25 also tells you you're at I. 11 is 3 after power of 8. So it's 8, 9, 10, 11. That tells me I cubed. I cubed is negative I. If you divided it, you get 0.75. Okay, 91. 91's a little harder, it's a little bigger, right? So 91, I know in my head 88's a multiple of 4, because I know 88 divided by 4. 89, 90, 91. So that's how I know 91 is the same as I cubed, which is negative I. Again, take 91 divided by 4, you get 0.75. That also tells you negative I. (244) divides by 4, therefore it is a power of 4, therefore it is equal to 1. 10 is 0.5, it is 2 after 8, therefore I squared, therefore negative 1. I to the 6th and I cubed have to be treated like adding x to the 6th and x cubed. Can you add x to the 6th and x cubed together? No, because they're not like terms. So I to the 6th and I cubed are not like terms. They are not equal to I to the 9th. You have to simplify each one separately. So I to the 6th is like I squared, which is -1. I cubed is negative I. So I to the 6th plus I cubed is really -1 minus I. Okay, turn to day 2 in your notes. The rest of today is really, really easy if you're good at combining like terms. So think of I like a variable x, right? If I have 3 plus 6i minus 4 minus 8i, I want to combine like terms after I distribute my negative. So I can't combine like terms until I distribute my negative. So this is really like 3 plus 6i minus 4 plus 8i. Like terms are numbers with numbers, i's with i's. So 3 minus 4, 6 plus 8. Distribute your negative. Combine real with real. So the real is 8 and -2. Imaginary with imaginary. A real plus an imaginary is known as a complex numbers. These are complex numbers. 11, distribute. Combine like terms. In 12, there's nothing to distribute. The parentheses kind of just go away. And we're just going to combine like terms. Remember, you kind of want to throw that curl on the I so it doesn't look like a 1. So adding and subtracting is really easy. It's like combining like terms if you're adding and subtracting variables. The reason we have to learn the powers of i's are for multiplication. So just like when you multiply variables together, their exponent changes. When you multiply i's together, the exponent changes. So 3 times 8 is 24. I times I becomes I squared. The rule for simplifying complex numbers is that no I can have any power in your final answer. So like if it was x's, you leave it as x squared. The rule for i's is that no powers can have any, that i's cannot be to any power. I squared, according to our chart, is equal to -1. So you replace the I to a power with its power of I. So 3i times 8i is really 24i squared. The 24i squared is really -24. 12 times 7 is 84. I times I is I squared. I squared is negative 1. So 12I times 7I is negative 84. You can multiply as many numbers together as you want. We know that. That's like our normal rule in math. So I would just group the first two terms. So negative I times 7I is negative 7I squared. That now gets multiplied by 4I. So 4 times negative 7 is negative 28I cubed. Go back to your powers of I cubed is negative I. A negative times a negative is a positive. So we get 28I. I'm going to show you on number 8 how you could do this slightly different. So in 8, again, I group the first two terms together. 3 times negative 3 is negative 9. I times I is I squared. We're going to distribute that to 4 minus 4I. But what you can do is you can distribute it with the I squared, or you can replace I squared with negative 1 first. So negative negative becomes 9 times 4 minus 4I. So again, I could have distributed with the I squareds and then changed I squared and I cubed. After, you can also change the I squared at any given time. It won't affect your final answer. Does that make sense? Before I just before I poured it right. And sometimes my board decides it's not going to write, or it's going to connect my writing. If something is raised to a power, that's really like saying you have that term twice. So this is like one of the biggest mistakes people tend to make. They tend to turn 3I quantity squared into 3I squared, and they forget that that squared goes to both the 3 and the I, making it 9I squared, not 3I squared. So again, this term here becomes 9I squared. So order of operations say exponents first, but that exponent goes to both terms because it's really the same as saying that. 2 times 9 is 18. I cubed is negative I. And again, you don't have to write this every time. If you're good to go from I cubed to negative 18I, that is also fine. Be careful. In 10, a negative times a negative is a positive. Any negative number squared is positive. So this becomes, again, 4I squared. 4 times 5 is 20. being positive or negative is so important because it really affects your value when you start to plug in the negative i's or the negative ones, etc. So your final answer should be negative 20i. The last part is FOIL. So again, a binomial times a binomial says you have to FOIL. So it is first, outer, inner, last. So you're going to end up with 4 terms. So 3 times 2 is 6. 3 times negative 4i is negative 12i. Negative 14i. Positive 28i squared. So just like when we FOIL, we have to combine like terms. So when we FOIL, we have to combine like terms. So negative 12 and negative 14 become negative 26i. I squared becomes negative 1. So this becomes minus 28, which makes the 6 and 28 like terms, which makes my final answer negative 22 minus 26i. A real plus an imaginary, a complex number. There's big old folks. First, outer, inner, last, combine like terms, change your I squared. So again, you have very similar processes and steps, combining like terms, changing squares. I squared becomes negative 1. That 15i squared becomes negative 15. 24 minus 15 is 9. Homework is front and back of that next page. It is mixed up, meaning I have multiplication in some spots. I have addition mixed with multiplication. I have subtraction mixed. Make sure if you need to FOIL, you FOIL. Make sure if you're distributing a negative, you distribute a negative. I can't tell you how often, since we did FOIL as our last examples, you try to FOIL the addition or subtraction problems on your homework. So just pay careful attention to if you are FOILing or adding and subtracting.